Okay, here's just a little demo I have ginned up of the central limit theorem using MATLAB. What you're seeing here at the top of the screen in figure 1 is a population I generated that is deliberately kind of a non-normal distribution. So this is a histogram of some population of some value. It doesn't really matter what the value is, but it can range apparently from -4 to 4. And you can see that, the shape of the distribution is not particularly normal, so it kind of has a lot of values towards the ends and also a lot of values in the middle. And what we're going to show at the bottom in figures 2 and 3 on the lower left and lower right is we're going to generate a couple of sampling distributions for different sample sizes. So let me go ahead and do one iteration of that just to show you what this is going to look like. So you see at the lower left, we're going to generate samples that are of size 3, so drawing 3 individuals from the population. And up at the top, we have put that on the graph you see little yellow lines. Those indicate the 3 individuals that were randomly sampled from the overall population. So one of them had a value of slightly over 1, one of them had a value of about 2.5, and one of them had a value, looks like, of like 3.25 or something like that. And that gave us a mean for that first sample that we plucked out of the population with size 3, mean of looks like about 2.25, something like that. And that's plotted on the lower left histogram. And then on the lower right, we show a sample size of 20. So in the upper diagram, that's all of the kind of cyan colored lines. And it looks like they had a mean of about 3/4 or something like that, a little bit less than 1. So obviously a histogram with one sample doesn't look like much. So let's go ahead and pluck a second random sample of each size out of the population above and advance that. Okay, so here's our new sample. We can see that we've got 3 new individuals plotted in yellow up above. Looks like they have values of -1.25 and about a quarter past the 0 point, and about 2.25. And so that should be let's see, that has a mean of something like 1/2, it looks like, if I caught those people correctly. That's in the lower left. And, then we've got a bunch more people on the lower right, another 20 people sampled on the lower right. And it looks like those mostly skew negative. So those have a mean of, looks like about -1.25, right? So I'll repeat this a few more times. And we'll just kind of plot the means of the samples, or the histogram of the means of all the samples. And obviously this is a running histogram down below. So, this is showing in these lower 2 graphs, the histogram of the means of all of the samples that we have plucked so far. And I'm just going to set it running now for a little while to go more quickly. So now we've plucked about 23, 24, 25 samples, and we're starting to build up histograms of these sampling distributions for samples of size 3 and size 20. And what you should start to see is that the larger sample size starts to approximate a normal they're both approximating a normal distribution, but the larger sample size is approximating a normal distribution sooner. Like, it doesn't take as many we don't need to do as many samples before we start to see that normal shape emerging. And it's kind of a cleaner normal shape, and it has a lower standard deviation, meaning like the width of that curve is lower. So I've kind of paused it here with 50 samples taken, so you can kind of take a look at that. What I'm going to do now, you'll notice up above, those lines are gone because that takes a long time to draw in MATLAB. So after this point, the samples will go much faster, and you can see these histograms build up much more rapidly. So I'm going to go ahead and unpause it now, and you'll see these histograms grow. And this should make it more clear, I think, that the larger sample size forms a nicer histogram. I mean, it's still a random process, so they're both pretty irregular. This is we're pausing again at 100 samples, and I'll just let this go now. I think it'll stop next to 1,000 samples. But hopefully you should be able to see that, generally speaking, the sample size of 20 makes a little bit of a nicer normal curve with an equivalent sample size. So with an equivalent number of samples taken. So you don't have to take as many samples to get a nice looking normal curve with the larger sample size. And just like you saw earlier on, the width of that histogram on the right is thinner because a larger sample size is going to lead to a lower standard deviation of the sampling distribution, aka a lower standard error of the mean. So we'll just let this run for a little while longer, but hopefully this does a good job of illustrating why larger samples, well, A, what a sampling distribution is in the first place, and B, why larger samples give you a lower standard deviation of the sampling distribution, which again is the standard deviation of the sampling distribution is known as the standard error of the mean. So I'll shut up now and just let you watch the rest of these histograms grow up to, I think I chose a total of 1,000 samples. Okay, quick pause to check in at 500 there, and still kind of looking like it's showing the same patterns as before, and we'll just unpause and go all the way to 1,000. Okay, and here we are finally at our total number of samples chosen, random samples of a total number of 1,000 random samples chosen for both sample size 3 and sample size 20. Hopefully you can now see that both of those sample sizes, sampling distributions, are doing a pretty good job of approximating a normal curve. Although again, you can see that I think the one on the right is a little bit nicer, and also one more time has a it's thinner from left to right. It's got a lower standard deviation, which is equivalent to saying that that sample size of 20 has a lower standard error than you would get with the sample size of 3. So I think that's pretty much everything. Hopefully that is helpful, and I'll see you later.